We've learned to take derivatives along a line of constant y, where x is changing, and we've learned to take them along a line of constant x, where y is changing. So these are two different partial derivatives of a function, but one thing that we can't currently do is ask how a function is changing if we move in an arbitrary direction. Here's the picture. We are able to find a partial derivative, to see how this function changes as we move in the x direction, and a partial derivative to see how this function changes as we move in the y direction. And we'd like to get off these axis directions to better understand changes in a function. And for this reason, and for a few other reasons that we'll come to, it's time to expand our toolbox. And the way we're going to expand our toolbox is by learning about vectors. So a vector is a quantity that has a direction and a magnitude. Here's a vector that goes from the point P to the point Q. So this vector gives us the displacement between these 2 points. There are a number of applications where a vector might come up. One common thing that has both a speed and a direction is you, when you're moving in a car or when you're walking around. You're moving at some speed and you're moving in some direction. Wind also has a speed and a direction. So does motion of water in the ocean or in a river. So lots of quantities that we might care of don't just have a speed, they have a speed and a direction. To construct the displacement vector between these 2 points, we have some pretty specific notation. We have vector v, and it's pointing from one point to another point. And the change in the x direction, as we move from this first point to this second point, is given by x2 minus x1. So the change in the x direction is right here. And then we need some way to indicate the direction that that change happened in. And so we use the vector I. So this notation where it's v with a little vector symbol above it, this is the symbol that we'll use to say something is a vector. So in the x direction, we're moving x2 minus x1 I. And in the y direction, we're moving y2 minus y1 j. So here are those vectors. This is the vector x2 minus x1 in the I direction. And this is the vector y2 minus y1 in the j direction. And added together, they give us this green vector that takes us over this amount in the I direction and up this amount in the j direction. If we move into 3D space, vectors have a k direction as well, to allow us to move along the z-axis. If we have 2 vectors, call them u and v, we might want to have a way to add them. To add 2 displacement vectors, we imagine that the start of one coincides with the end of another. This means that the total displacement of u plus v is whatever our x displacement was along the I direction for u, plus whatever our x displacement was along the I direction for v. That's our new I displacement. And then along the j direction, it's whatever our u displacement was plus whatever our v displacement was. And so order really doesn't matter. Whether we went with this displacement and then that displacement, or vice versa, we would get to the same point. So here we are traversing first v and then u instead of first u and then v, and you can see that they lead to the same place. We might also want to figure out how to multiply a vector by a scalar. So if we have a vector u, perhaps we would like to be able to take 1.5 times u. To do that, we simply stretch the displacement along the I direction to 1.5 times the original, and we stretch the displacement along the j direction to 1.5 times the original. Or we might want to be able to take negative u. To do that, we simply take negative 1 times the x displacement, that takes us here, and negative 1 times the y displacement, that takes us here. And so u and negative u are exactly the same length, but they're pointing in perfectly opposite directions. If we were to add them together, we would get 0. In addition, we want to define the magnitude of a vector. So a vector has a direction, and it also has a magnitude. The magnitude is its length and is denoted with these double bars. So this means take the magnitude of u, meaning take its length.